simplify sine of x plus cotangent of x cosine of x. Notice that even though I have something plus something, I can't take out a GCF. I can't factor quite yet because I don't have a common factor. Right? I have like 3 different functions going on. So let's see, when I see cotangent of x, I can rewrite that in terms of cosine and sine. So I chose to rewrite cotangent of x as cosine of x over sine of x versus 1 over tangent of x because I saw that in the rest of my expression I had cosines and cosines and not tangent. So notice right here I have cosine of x over sine of x times cosine of x, and that's really like over 1. So when I multiply straight across, I get cosine squared x over sine of x. And notice sine of x is really also over 1, right? So I can combine these two fractions together by getting a common denominator. Okay, so when I get a common denominator of sine of x, right, I put that as my same denominator here, over a single fraction, I get sine squared x plus cosine squared x all over sine of x. And I hope you could notice here that sine squared x plus cosine squared x is equal to 1. So I end up with 1 over sine of x, which is equivalent to cosecant of x. It's the reciprocal identity. Final answer, cosecant of x. Again, let's recap what we had to do here. I couldn't factor out because I didn't have any common factors, so I replaced one of the terms to something else I knew was true. And then I multiplied to get a single fraction. Then I noticed that I had 2 separate terms that I could combine as a single fraction by getting common denominators. Then I replaced sine squared plus cosine squared with one of the Pythagorean identities, and then I replaced this term here using the reciprocal identity. Okay, your turn. Cosecant of x minus cosine of x cotangent of x. Go ahead and simplify this. Okay, the correct answer is sine of x. When I see cosecant of x and cotangent of x, I have the immediate sense that I'm going to replace them with their reciprocal or quotient identities. So cosecant of x I replaced with 1 over sine of x, and cotangent of x I have the option of replacing with cosine x over sine of x or 1 over tangent of x. But I chose cosine of x over sine of x because I saw that in the other locations, those are the terms that I had. When I multiply straight across here, I get cosine squared x over sine of x, and in this case, I have 2 fractions who already have the same denominator. So I rewrote it as a single fraction, and notice that 1 minus cosine squared x, right, 1 minus cosine squared x is equal to sine squared x. And when I have sine squared x over sine of x, one of the sine of x's cancel out, giving me sine of x as the final answer. Okay, last example. It says rewrite 1 over 1 plus sine of x so that it is not in fractional form. So our final answer should be simplified such that it's just no longer in a fraction. So for these problems where you want to rewrite so that it's not in fractional form, you would need to do the following. You rationalize a denominator, okay, by multiplying by the conjugate in a form of 1. So here's what I mean by this. So if I have 1 plus sine of x in the denominator, the conjugate would be 1 minus sine of x. Remember, the conjugate is where the 2 terms stay the same, but it's just the middle sign changes. One's going to be plus, one's going to be minus. If you had a minus, you would have a plus. But I can't just randomly multiply by something, right? I can multiply it by a form of 1, or it has to be in the form of a 1 so that I'm not changing the value of the original expression. So I multiply by 1 minus sine of x over 1 minus sine of x. When I multiply straight across, 1 times 1 minus sine of x gives me 1 minus sine of x. And 1 plus sine of x times 1 minus sine of x, because these are conjugates, when I FOIL, right, the middle terms cancel out, and I end up with 1 minus sine squared x. So right here, some of you might be tempted to factor 1 minus sine squared x into 1 plus sine of x and 1 minus sine of x, canceling out the 1 minus sine of x's. But then you would just get back what we originally started with. So we don't want to take that approach. What can we do instead when we see 1 minus sine squared x? I hope you can recognize that 1 minus sine squared x is equal to cosine squared x. So you want to substitute with cosine squared x. Okay, so my expression is still in fractional form. So what can I do? I can separate these into two fractions. Okay, so I've separated into two separate fractions, 1 over cosine squared x minus sine of x over cosine squared x. How could I rewrite 1 over cosine squared x? Well, that's equivalent to, right, secant squared x. And then how about here, sine of x over cosine squared x? Okay, so you can think of it as sine of x over cosine of x times 1 over cosine of x. Do you see how you can separate as two fractions multiplied together? Yeah. So sine of x over cosine of x can be rewritten as tangent of x, and then 1 over cosine of x can be rewritten as secant of x. So this is your final answer, secant squared x minus tangent of x, secant of x. Okay, let's go ahead and think back to what we had to do. We were given a fractional form. You multiply it by the conjugate in the form of a 1. And we multiply straight across and replace the denominator with an equivalent value or equivalent term. And then we separated the fraction to two separate fractions, and we replaced the fractions into using their reciprocal identities or quotient identities. So 1 over cosine squared x became secant squared x, and then sine of x over cosine squared x became sine over cosine, which is tangent of x, and 1 over cosine, which is secant of x. So again, the whole point was to try to get a non-fraction, which we did at the end, and you had to go through a bunch of steps to do that. Okay, your turn. Rewrite cosine squared x over 1 minus sine of x so that it's not in fractional form. Your final answer should be 1 plus sine of x. So you multiply by the conjugate of the denominator in the form of 1. When I multiply straight across, I keep it in factored form at first because I have cosine squared x times 1 plus sine of x in the numerator. In the denominator, when I multiply straight through, I get 1 minus sine squared x. So the 1 minus sine squared x I can replace with cosine squared x. And so now you're able to cancel out the cosine squared x since it's still in factored form. So if you didn't have it in factored form, then you would have had to factor again so that you can cancel out the cosine squared x's. Or you could have canceled out cosine squared x from each of those terms. And your final answer is 1 plus sine of x. Here I'm just showing you the work if you were to have distributed the cosine squared x at the beginning, right? What it would look like. You would end up with the following, and then you could separate it into two fractions here. And the cosine squared x cancel out, giving you a 1. Cosine squared x cancel out here, giving you a plus sine of x. So you end up with the same answer.